Hi everyone, welcome back to our course manufacturing process. Today we are going to discuss about bulk deformation process. One of the most widely used bulk deformation process is forging. So what are the parameters affecting forging? What are the applications of forging? Process dynamics of forging. These are the things we are going to discuss today. So the learning outcome is describe various metal forming process, including forging, and compute their process dynamics and performance. Forging is one of the oldest metal forming operation. It's around about 5000 BC. Deformation process. It's a deformation process in which the part is compressed between two dies. In olden days, people used to heat the part in the shape and size. So components such as engine, crankshafts, connecting rods, gears, aircraft structural components, just jet engine parts, wherever we need a strong part, this manufacturing process called forging is very important, and that's why in engine crankshaft where we have fluctuating loads, connecting rods, etc., we are going for forging process to produce very strong parts. Also, basic metals in industries uses forging to establish basic form of large parts that are subsequently machined. In some cases, we can produce parts and then later we can machine the part to finish the final shape and size. So there are two types of forging operations. We have cold and hot forging operations. Hot forging, if it is done at elevated temperature above recrystallization temperature, a significant deformation of the material is possible. Also, it increases the ductility. This is the advantage of hot forging process. Is accuracy and finishing. But whereas cold forging process, if it is done at room temperature, the advantage is strength will be very good and excellent. That results because of the strain hardening. So there are two types of hammers. Forge hammer, if we apply sudden impact, sudden load, that is called forge hammer, hammering. And then we use a forging press, which is where we apply gradual pressure by hydraulically or by some other or motorized techniques. We are applying a gradual pressure that is called a forge press. So these are the two methods where we can apply the force and we can and size of a material using forging operation. What are the types of forging dies? We have three types of forging dies. They are open die, impression die, and flashless forging die. Let us see them clearly and let us understand how they work. In open die forging, work is compressed between two dies, allowing metal to flow laterally. Look at that. They are compressed. The workpiece is compressed between two dies, allowing the lateral flow of the material. The material can flow laterally. Definitely, when we apply compressive stress, in forging operation, we are applying compressive stress. Material will get compressed. Material will undergo deformation, plastic deformation. The diameter of the material will increase and the height decreases. So there will be a lateral flow of the material. So we have minimum constraint in the lateral direction in open die forging. Now you can see here in impression die forging, there is a particular shape to be produced. So dies are produced, the upper die and lower dies are produced based on the shape of the material, based on the shape of the part to be produced. So when we apply a load, the material will undergo plastic deformation because of compressive stress. Flow of the material takes place, but some material also will come out through the gap. This is called flash produced. So impression die forging, it is a very good forging technique which contains cavity or impression that is imparted to the work part. Metal flow is constrained, but there is some amount of additional material which protrudes or which flows through the gap. This is called flash, which is unwanted, need to be removed by metal cutting techniques. Flashless forging, there will not be any flash. The material will be completely constrained in the die. So this process is called, this forging operation is called flashless forging operation. As the punch moves downwards, the material will get compressed. Punch and die has a shape, the final shape of the material or the part to be produced. There will not be any flash or unwanted or wastage of material in flashless forging technique. So open die forging, as I explained before, two flat dies. When we compress it, the work part cross section will increase. That means the diameter of the material will increase and the height decrease. So height decreases and diameter increases. Common name of open die forging is upsetting or upset forging. So here in open forging, there is no constraint or there is no restriction in lateral flow of the material. So if we analyze open die forging in two conditions, one, the open die forging, that means a simple type of forging operation between two dies, one open upper die and a lower die, and then we apply a compressive stress. The height decreases and diameter increases. What kind of analysis we can die in such cases of forging operations? No. Now we can see that one without any friction and second with friction. So if you see that the normal equations which are applied for other operations that could be applied for open die forgings without friction, the true strain is equal to log H naught over H. H naught is the initial height before forging operation or starting height, and H is the height after compression process. So this is called a true strain value. The strain will be maximum. The true strain will be maximum when the value of H becomes final height. When H is equal to HF, the strain becomes maximum. At that condition, the material will get compressed at its maximum condition. Now the flow force required for forging operation is equal to flow stress times area. Flow stress, as we have studied before, K epsilon raised to n over 1 plus n. K is strength coefficient, epsilon is true strain, n is strain hardening index, divided by 1 plus n, which is the flow stress times area, cross sectional area. So normal equations, whatever we have studied, which are applied for the forming operation, that could be applied for forging also without any friction condition. But here certain assumptions are there. Area increases continuously, as you know. Flow stress also increases due to work hardening. You know, if it is a hard working process, the n becomes 0. That means we assume that the flow stress remains constant. So force will be equal to maximum at the end of the forging stroke. This is one of the important things we have to understand in a forging or in an open die forging operation. Now, if this is the conditions here, when we start forging without any friction, naturally the height will decrease. This is intermediate condition. As we keep on applying the compressive stress, the height decreases, diameter increases. At the end, what happens? Height becomes less and diameter becomes maximum. This is the final size. So you will be getting a uniform cross section, or we can say a homogeneous produced. Any place you cut, you will get homogeneous structure in here. So we are assuming that there is no friction. Now, but if you take the friction into account, that happens in a real scenario when the friction between the workpiece and the die. There is a friction between the workpiece and the upper die. There is a friction between the workpiece and the lower die. This friction will definitely affect the shape of the final product, as you could see here, and it happens more predominantly in hard working process because of sudden heat transfer. The metal part, which is in contact with the metal surface or the workpiece surface, cools faster. It resists the deformation process. As you could see here, when this is the initial condition, and when we keep on applying the force, the material will get compressed, but the material which is close to the die, it will resist deformation, and the other part will deform quickly. So what you can see is there is an effect called effect is because of the friction between the work and the die surface, and because of the friction between the die surface and the workpiece, this will resist the flow of the material to deform, and there will be a flow of material in lateral direction, which is away from the surface of contact, and this effect is called barreling effect. In hot open die forging, the effect is more pronounced due to heat transfer at near the die surface, which cools the metal and increases its resistance to deformation. As you could see here, because of friction effect, the material will resist to deform, and also because of the heat effect, material suddenly cools and it resists to deform. That's why you can see here a distorted shape will be formed because of the barreling effect. So this is starting, this is partial deformation, and this is the final deformation. Now, we need to take into account the shape of the final finished product in open die forging with friction. That's why in normal equations, what we in an ideal case, what equation we have is to calculate force is F is equal to stress times area. Simply F is equal to stress times area. But accounting the friction with the barreling effect, the shape has changed. The shape of the material has changed. The shape has there is a distortion in the shape. So we need to incorporate a factor called shape factor into the equation. So if force is equal to Kf, the shape factor, multiplied by stress times area, that will give you the resultant force applied during forging. So Kf is the force which is equal to 1 plus 0.4 mu d over h. That means the value will be greater than 1, and that means you need to apply more force rather than the ideal case because of friction or because of barreling effect. So Kf is equal to 1, the shape factor Kf is equal to 1 plus 0.4 mu d over h. Mu is the coefficient of friction, d is the diameter, and h is the height. So definitely Kf will be great if it is greater than 1. If greater than 1 means, Kf value greater than 1 means you will need to apply a force which is more than the ideal force required for forging operation. This is basically because of the friction and a barreling effect. So thank you very much for watching part 1. We are going to discuss this example in the tutorial. Thank you very much for watching part 1 of this video.